All right, chapter 9, section 4, we're going to graph sine and cosine functions. This is going to be weird. I'll tell you right now, this is going to be weird. It's very different from plotting points on an XY and drawing lines and stuff like that. But it's not as hard as it appears, I promise. So today we're going to go over like the mechanics behind it, and then tomorrow we're going to do the examples. So when we talk about graphing sine and cosine functions, this is what it looks like. They're called waves. You guys have seen these before, just probably never knew what it was talking about and stuff like that. We're going to focus right now on sine and cosine. We're not going to worry about tangent or anything like that. So these are the two parent functions of the sine and the cosine graph. They look very similar, yes. They look similar, correct? We're going to talk about the differences in them and that sort of a thing. But these are the parent functions. Parent function means this is what it looks like originally, and then we can do stuff with it. We can move it left and right. We can make it negative. We can stretch it, shrink it, that sort of a thing. But if you notice here in the sine, sine's on the top. Do you see how it says y equals sine of x? Your sine graph is always going to start here at 0. So write that down. Sine starts at 0. That's important for you guys to understand. It starts at 0. If you look at the cosine graph, here's cosine. See where it's, whoops, I didn't mean to cross it out, sorry. Do you see where we have y equals the cosine? Where does this start? Where does this start? Is that at 0? No, in this case it's 1 or something like that. But we're going to say that this starts, let me write in a different color. Cosine starts, and we're going to talk about what this word means here in a second, but starts at the amplitude. We'll talk about some vocab here in a minute. There's 3 really important things that we're going to have to figure out. But your sine starts at 0. Your cosine is going to start at the amplitude. Okay? Everybody with me on that? This is all dependent upon the unit circle. If you look here, I have 0, pi over 2, pi, 3 pi over 2 pi. All they've done is take a circle like this. This is our 0, pi over 2, pi, and 3 pi over 2. This is also 2 pi, right? So all they've done is taken that circle and like cut it open here and just pulled it apart, laid it flat. That's what you're visually looking at there. All right, so here's some characteristics of the graph that you guys need to be familiar with. First thing I want you to notice that it says the domain of each of these functions is all real numbers. Negative infinity to positive infinity. That means your x values are negative infinity to positive infinity. When we look at both of these, you guys see the arrows at the end? Yeah, sure. Do you see the arrows at the end of the graph? That means it goes on forever. This wave just keeps continuing in both directions, left and right. Okay, that's what that means. The range of the parent function is the highest it goes is positive 1, the lowest it goes is negative 1. It's your minimum and maximum value of the parent function. That'll change, but it's all it does is just go for the parent function. The highest it goes is 1, the lowest it goes is negative 1. The highest it goes is 1, and it keeps going back to the x-axis. At some point, it always goes back through the x-axis. So when we talk about the amplitude is how high and low the graph goes. And I'll talk about where that is in the equation, how you can figure it out. It's not that hard. Each function is periodic, which means its graph has a repeating pattern. It's periodic because it does the same thing for a never-ending period of time. It's going to go up and then down and up in the exact same increments the whole time. The shortest repeating portion of the graph is called a cycle. And then you're going to talk about the length of each cycle, which is called the period. So if you look at this, guys, look. You have one period right here. It's from 0, and it ends at what? What does it end at? It ends at 2 pi. What is that? From 0 to 2 pi, it's what? One whole circle. So then when this does this again, it does what? Another whole circle. Then it does it again, and it's another whole circle. So it's just this pattern right here in one cycle from 0 to 2 pi or whatever it is, whatever the one cycle is, it just keeps repeating the same thing every single time. That's what you guys need to understand, is that the pattern from the little shortest part that they say what the cycle is, the pattern does the same thing the whole time, okay? We're not going to get that much into it, I promise. So let's talk about this. This little slide, obviously this isn't from the book. I wrote this all by myself. I don't think we're going to get too much into this. This is from my pre-calc stuff. But you guys are going to need to know these things. You're going to need to know the A. Notice where A is. A is in front of the trig function. God bless you. So it's the number in front of sine or cosine. That is the amplitude. That's how high and low that the graph goes. All right, we're going to always find the A value. Then we're going to talk about the B. B is the number that's right in front of x. It's being multiplied by x. That's going to tell us the time period. How we find the time period? You take 2 pi divided by the b. And we'll talk about this a little more. Phase shift and vertical shift, we're not going to talk about right now. But we're going to talk about the A, the B, and we're also going to find the increments. Increments. That just means in the period what it's chopped up into. How do you find the increments? You take the period and divide by 4. Again, I'm going to go over these with you, and you're going to see it's not as difficult as it appears. When we graph, we need to find 5 key points. I know some of you are like, what in the world are you talking about? It's not going to be that hard, I promise. I'm going to do 2 examples here in a second. All right, what I just went over is pretty much right here. If you look here, A is, look, the number right here in front of the function is your A. That's your amplitude. That's how high and low the graph goes. B is the number being multiplied to the x. All right, we're going to use that B value to find the period. You take 2 pi divided by B, and that gives you the time period. And then once you find your time period, to find the increments, you divide that into 4 pieces as well. So let's just do a couple of examples. There's 4 more examples that I'm going to do tomorrow, and then I'm going to let you guys work on your homework. But some of the homework you can get done tonight if you want to start working on it. So if we're going to graph, it says identify the amplitude and period of this function right here. And then we're going to graph it. So the first thing I'm going to do is say, okay, g of x, you could write a y if you want to, equals 4 times the sine of x. We need to identify, before we graph, we need to identify the amplitude. We need to identify the time period. And then we need to identify what that time period is broken up into, the increments, the pieces. So let's identify the 2 major things that we need to know. What is the A value? What is the number in front of the trig function? 4, okay. And then our B value. What is the number being multiplied to x? 1, okay, perfect. Once you guys have that, the rest of this is really easy. So the amplitude is the number in front of the function that tells you how high and low the graph goes. What is it? 4. We'll talk about what negatives do and all that stuff, but 4 is your amplitude. So we can go ahead and start graphing this. Your graph's going to look something like this. What's the highest that this graph is going to go? Positive 4. What's the lowest this graph is going to go? Perfect. Negative 4. If it was 7, the highest it would go is 7, the lowest it would go is negative 7. If it was negative 5, the highest it goes is 5, the lowest it goes is 5. What the negative means is the direction. I'll tell you that in a minute. We don't do that right now. So my amplitude is 4. Now the periods. How do you find the time period? What did I tell you to do? The period is 2 pi. You always start off with one whole circle, and you divide it by the B value. So I say 2 pi divided by 1 equals what? 2 pi. So your period means the last tick mark on your graph is going to be 2 pi. So you're starting at 0, and you're going to 2 pi. Now, we got to break up the pieces in the middle there. How do we find out the increments? What do we know we're going to break this into? How many pieces? 4 pieces. So you take the period and divide by 4. So I take 2 pi divided by 4 gives me what? Guys, what's 2 pi divided by 4? half, so pi over 2. So in between each tick mark is pi over 2 units. So I start here at 0, right? I'm at 0. I have 1, 2, 3, 1, 2, 3, 4, and here's 5, right? 5 key points. You always have your starting and ending, then you find the ones in the middle. So my first tick mark, my first period is pi over 2. So I'm going to add another, if I add pi over 2 to that, what's pi over 2 plus pi over 2? What's 1 pi plus 1 pi? So 2 pi over 2, which equals what? Just pi. So then I add another pi over 2. If I have 2 pi over 2 plus 1 pi over 2, it equals what? 3 pi over 2. So if I add another to that, if I have 3 pi over 2 plus 1 pi over 2, I get what? 4 pi over 2, which is 2 pi. You just add. From each tick mark to the next, you add whatever the increment is. Now we're going to graph it. What kind of a function is this? Sine or cosine? Sine. Sine starts where? At 0. If it was cosine, where would you start? At the amplitude. This is a positive function. I know it's positive because there's not a negative sign right here. So I'm going to start at 0, and since it's positive, which direction do you think I'm going to go? Right. And which way, up or down? Up. So I'm going to go up to 4. Then I go where? Down to where? 0. Then I go down to -4. Then I go up to where? 0. And you just connect the dots in a nice little curve. If you were going to do another cycle, it would look the exact same way. You'd go up to 4, down to 0, down to -4, back to 0. You just go amplitude, x-axis, amplitude, x-axis the whole way. Now, we can do phase shifts where you move it left and right and that sort of thing. If, just saying, it's not, but what if your function, I'll do this in pink. No, I'll do it in this blue. What if your function was y equals -4 sine of x? How did that change? What's your amplitude still? Your amplitude is still 4. Still goes up to 4 and down to 4. But when I start at 0, where would my first dot have gone? Down. So it would have been a reflection like this. It would look like that. This one would be in blue. Do you see that? The negative just tells direction. If you have a positive function, you start at the point and go up. If you have a negative function, you start at the starting point and go which direction? Down. That's it. That is, so let's look at this. Identify the amplitude period, and we're going to graph. So let's write the function out. I'm going to just use y. So y equals 1/2 cosine of 2 pi x. Okay. So let's identify. What is A? What's my amplitude? What's the number in front of the function? 1/2. So tell me right now about, what does that tell me? My graph goes up how much? 1/2 and down how much? Perfect. What is your B value? What is the number that's being multiplied right there? You can just use just the 2. All right, so let's talk about, I need my amplitude. I need my time period. And I need the increments. So I already know my amplitude is 1/2. So if I start my graph, the highest it goes is positive 1/2. The lowest it goes is what? Negative 1/2. Am I being like super particular? No, just make sure you mark it. And then this is 0, okay? So remind me again, guys, how do you find the time period? It's 2 pi divided by what? The B value. Well, in this case, what's the B value? 2. So what is the time period that we're talking about here? Just pi. It's not one whole circle. It's how much of a circle? Half. All right. So 0 is my starting over here. So what's my ending over here going to be? The whole period is just pi. Good. That gives you your starting and your ending. And now you figure out all the tick marks in between. I have to cut it into how many pieces? To find the increments, I cut it into how many pieces? You take the time period and divide it by what number? Nope. How do you find the increments? It's the time period divided by 4. Cut it into 4 pieces. How many quadrants are on a coordinate plane? 4. right? First quadrant, second quadrant, third quadrant, fourth. How many quarters are in a circle? 4. So my first tick mark is going to be pi over 4. That's my first one. So my second tick mark, I'm going to add another pi over 4. Well, what's pi over 4 plus pi over 4? 2 pi over 4, which is 1/2. Good. I'm going to add another pi over 4, and I get what? 3 pi over 4. Good. And then my end one, if I add another from 3 pi over 4, if I add another pi over 4, what do I get? 4 pi over 4, which is pi, which is where you need to stop. You're always just going to add. Go from 0 and then add the first increment, then the next one. It's just going to all be the same. So now let's talk about how we graph this. If I have a cosine graph, where do I start? At 0 or the amplitude? The amplitude, good. Is this a positive cosine graph or a negative one? It's a positive one. So I'm going to start at the amplitude of what? Positive 1/2 or negative? Positive. If it was negative, I'd start where? Down. So I start here at the positive, and then I go where? Well, we already started up. So we're going to go to 0. Then I go where? I got to go to negative 1/2. Then I go where? Back to 0. And then I go where? Back up. If I was going to continue this pattern, where would the next one go? Back to 0, then down, back to 0. And it's just a nice little wave, just like this. Cosine starts at the amplitude. If it's a positive number, you start at the positive amplitude. If it's a negative number, you start at the negative one. That's it. So the 3 things you have to remember, guys, the a value, the number in front of the trig function, that's your amplitude, how high and low. To find the time period, you take 2 pi, which is one whole circle, divided by the number that's in front of the x. And then to find the increments, you take that time period and divide it into 4 pieces. And then you just put it on the graph. So these 4, I know you guys see them here, these 4 I will do tomorrow. We'll work on it. I will do all of them with you. And then you can start your homework. You have the weekend to do your homework. I'll go over the homework and stuff on Monday. And we'll start the test review. Go over your quizzes. We'll go over the test review Tuesday in class. And then on Wednesday, you'll have your quiz. The good thing for you, I know you guys aren't going to think this is good, but Monday and Tuesday, the A and C are longer, so it gives us a little more time. I know you're like, yay, I get to be in math for a really long time. It's not that bad.